Hi, in this video I'm going to explain how to use some common PowerShell commands to work with files and paths. So here I have a PowerShell window open, and the first command I'm going to demonstrate is one of the first commands people often learn is ls or dir. Those are both aliases for PowerShell commands to list files. So I'm going to type ls, hit return, and this just gives me a listing of all the files and subdirectories in the current directory. So the current directory is shown on the PowerShell prompt. And here it shows that I have in this directory, I have a data subdirectory. That's the mode is showing that it's a directory, and its name is data, and there's no other files in this directory. I can also type ls data. I'm going to hit tab to autocomplete that. And this will show, instead of showing the files in the current directory, it'll show the files in the data subdirectory. And we see I have a whole bunch of text files in that directory, file 10 through file 99. And so this is showing the contents of that directory. So we can see that the directory it's showing is this is the full path of that directory, and we can see that its contents include these files. So the concept of a path is something that you essentially walk on to get from the root of the namespace of files, if you will, down to a particular place. So starting on Windows, the path usually starts, a local file path usually starts with a drive letter. So we start on drive C, and then from the root directory, indicated by the backslash, we then go into the learn ps subdirectory, and then from there into the files subdirectory, and there into the data subdirectory, and then all these files, particular files, are in that subdirectory. And like pretty much any command, we can assign the result of that listing to a variable. So let's do that same command, but we'll just assign the result to a variable called files. And now instead of there being any output, instead we have the listing of files saved in this variable. And so what is this variable? It's a, say, files get type. To find out what the variable's type is, it's an array, system array. And because it's an array, we can ask how long it is or what its count is. And there are 90 elements in that array, and we can access the individual files like so. The first element is at index 0. Oops, sorry, I forgot the S. Files 0, and we can see that the first element is an object that includes these properties. And here it's shown in sort of a tabular format. We see that this listing is very similar to what we saw when we got the directory as a whole, but it's just showing the first item. And if we want to show the second item, we can do that like so, item at index 1, and so on. So in addition, we can say files1, instead of formatting it as a table, we can format it as a list. And now instead of seeing the properties in columns, we see the properties, each property is a row. And so the name is this, the length is this, and the creation time, and so on. So format list shows more properties than format table does. So we have additional properties. There's more room to show all those properties. And we can also specify, even that doesn't show all the properties. If we want to show all the properties, we can say -property, and we can specify which properties we're interested in, and just saying star will show all of them. So we see that now we have, for the first file, we have all these different properties. It has the drive, it has the provider, which is the file system provider. It has the one of the most useful ones, it has the full name. So this is the full name of the file instead of just the file name itself. So there's a name, which is just the name itself, and then there's the full name, which is the full path. Okay, so that's getting a directory listing. And again, we are able to assign it to a variable. We're also able to pipe it. The directory listing gives you an array of objects, of file info objects. One thing that I should mention is that I was typing ls. That's really just a shortcut for the Get-ChildItem command. So if I type get help ls, then the help that it shows is actually for the real command, which is Get-ChildItem. That's the real PowerShell commandlet for listing And it has this very generic sounding name because you can list not just files, but anything that is kind of that supports enumerating. There are other things besides files that can be enumerated using Get-ChildItem. For example, registry keys and registry values and so on. So that's why it has this generic sounding name. And it has a lot of different, it's very flexible, but the way we're using it is quite simple. Okay, so the next thing I want to show is, let's do that same command, ls data, and now we're going to redirect that using this redirection operator, the right angle bracket, redirect the output of that command to a file, and I'll just call it files.txt. Okay. So now, if we get a listing of the current directory, we see that there's now a files.txt file. And if we look at the contents of that, I'm just going to run Visual Studio Code. I'll run code files.txt to open that file in Visual Studio Code. And here I'll move these windows side by side. And so now we can see that the contents of the files.txt are exactly the same as what we would get by running the command without that redirection. So if we type ls data without any redirection, we see that the output of the command as it's written to the console is just what we get in files.txt. So one thing I want to point out is this is the formatted output, just as it would have been written to the console. So the command gives the ls command, or Get-ChildItem command, or dir is the other way, dir. It gives an array of objects, array of file info objects. When it gets formatted for the console, it converts that to a tabular format that's to be human readable. There is another way we can, so when we use the redirection command, it takes that formatted output that would have been written to the console and instead writes it to this file. Now there's another way to save the output of a command, or the result of a command, to a file, and I'm going to do that now. So instead of saying right angle bracket files.txt, I'm going to use the pipe symbol, the pipe operator. And what this does is it pipes the output of one command, takes the pipeline, so the first command sends its output to what's called the pipeline. And now we take that pipeline output and pass it as input to the next command. So we have another command on the right-hand side, and this command is going to be called, I'm going to use set content, and I'm going to say files.txt. Okay? So what this is going to do is it's going to set the content of files.txt. That is, create a file called files.txt or overwrite the existing file. And the contents it's going to write is the output of the previous command, or the output of the pipeline. So let's run this, and we see that the content is a bit different than what we saw from the redirection. And the reason is that it's not taking the formatted output of the command, it's just taking the actual objects from the command, converting each one to a string, and saving that as a line of text in the output file. So if we go back to our files variable here, remember if we had files 0, for example. So that was a if we say get type. So that was a file info object. And when we did the formatted output, it showed the different properties of that file info object in a tabular format. But when we just convert it to a string, what it does is it takes just one of those. In this case, each object has a different way of converting to a string, and we can find out what that is by calling that object's toString method, and we see that it actually just converts it to the full path of the file. So now we have so each of the files is written as its string representation, its full path to that text file. Okay, so that's we learned about Get-ChildItem, or LS, and that actually gives you an array of file system info objects, or file info objects rather, and we learned how we can store that information, write that information to a file in one of two ways, either by redirecting the output using the angle bracket operator, or by using the set content command, which is the one that we've just used now. So along with set content, there's a get content command. So I can say, I'll just say data equals get content files.txt. All right. So this is kind of the reverse of set content. Set content took some input and wrote it to a text file. Get-content will read the text file and give it back as an array of strings. So if we say data get type, we see that it's an array. And if we look at data count, we see that it has 90 members in that array, 90 elements in the array. And if we look at data 0, we see that data 0 is equal to that first line of the file. And data 1 is going to be equal to the second line of the file, and so on. And each of those values in the array is simply a string. Okay, that's the type of that object. Okay, so let's try using this in a PowerShell script. So I'm going to invoke Visual Studio Code again. Excuse me. And I'm going to create a script called paths.ps1. Okay, so now we have our files.txt, and we have a script called paths.ps1, and I'm going to use that get-content command, get-content files.txt. The quotation marks are optional, but I like using them. And if I just do that by itself, it's just going to output the files, it's going to send the output to the console. So if I run paths.ps1 here, then it just reads the content of that file and outputs each line to the output. But now let's do something with it. We'll use the pipe operator again. And again, we're taking the pipeline output from the get-content command, which is simply all the strings in that file, all the lines of that file. And we're going to send that as input to the next command. The next command I'm going to use is called for each object. Oops. For each object. Why am I not getting completion here? Oh well, okay. For each object, there we go. And so the command what happens, what this means is that the code block defined by surrounded by these curly braces here, that's the argument to for each object. For each object will take its input, which is the name, for each object will be invoked once. Let's see, how do I put this? This code block in the curly braces will be invoked once for each object that is passed to the for each object command. So in other words, we get 90 different file names that are read by the get-content command that produces this array of strings. And then for each of those strings, we invoke this code block. And then within the code block, there's this pipeline variable called $_. That's kind of the magic name of the pipeline variable. That variable is equal to whatever the current string is. So I'm going to just say hello, like so. Okay, hello, whatever that string is, hello variable, and what we should see then is hello learn ps files data file 10.txt, and then the same thing for the next one, and so on. So let's run our script again, and we see that yes, we're actually executing this command once for each file name, or once for each line of that file. Okay, so let's do something a little bit more complicated. Let's try learning another PowerShell command, and this one is called test path. Okay, so test path, what does that do? So what this does is it checks to see whether the path, a path again, remember, is just either the full name or a partial name of a file. So it can be a full path from the root of the file system, or it can be a relative path from the current location, or it can just be a file name in the current directory. And what this does is it checks to see if that file actually exists. And if it does, it returns true, and if it doesn't, it returns false. So the value that's returned is either a true or false value. That's called a Boolean value. And so it can be used to do things like, you can use it in an if statement or something like that. But in this case, let's just output the value of test path, and what we'll get is it just writes true 90 times, because all of the files in this files.txt file exist. So there we go. Let's just, in order to test this further, let's add another line to this file, and we'll call it no such file. no such file. Okay, so now we have 90 files that exist and one file that doesn't exist. And now if we invoke our command again, we get true, 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 false. Okay, well that's very interesting, but just outputting true or false to the console is not very useful. What if we make some decision based on that? Let's do an if test. Now let's say if test path such and such, then okay. Now if we run this, we see, oops, that should have been a $sign, not a %sign. My fingers are remembering old legacy batch file days. Okay, so so now we see that we're writing, 60, 80, etc. up to file 99 exists. We didn't write anything for the last file that doesn't exist. Okay, but what I'm really more interested in is what we can do here is we can say, I'm just going to put in a comment, do something with this file. This is sort of a, I'm going to set an else, and then here this would be like the error case. So this is the case where the file exists. Let's say file exists, do something with it. And then otherwise write host again with the %signs. Okay, $sign. Okay, let's try that. And then we see the only for most of the files existed, and so we just had nothing but a comment. But there was one file that doesn't exist, and so we output our error message. So there's an example of the test path command. And by the way, it's a consistent thing in PowerShell that commands that return a Boolean value generally are named test something or other. So there are other path commands besides test path. There's join path and split path and resolve path. So let me show you those really quick. So let's go back to our command prompt. Let's say path equals paths. I think I had a paths variable. Oh, let's just take this. Okay. Path equals so and so. All right. So actually, let's do this. Path equals data file 96.txt. All right, so this is a relative path to this file. I can say resolve path. Okay, this takes the relative path that I passed in and converts it to a full path. Actually, it converts it to an object that has a path member, which is a string. So I can say resolve path, and then we just get the string itself. If I say resolve path without the dot path, I can say get type, and this is a path info object. So the resolve path returns a path info that has various properties, and one of those is the actual path. Okay, so that's resolve path. There's also join path and split path. So let's take a look at those in turn. So we can say split path. So again, path by itself is data file 96.txt. Split path would give us the parent of it. Or let's say path equals resolve path. Okay, and then we'll say split path. So now path is the full path, right? We can say split path is now just the parent part. So it's taken the file name, remove that, and we can say split path. Okay, now we're going to split the path to get the parent, and we're going to split it again to get the parent of that, and then we should see learn PS files. So we had the full path that included the file name. Split path lopped off the file name, gave us the parent. Split path again lopped off the top level, the last part of the path, and gave us the parent of its parent. So split path by default will give you the parent. Hello? You can also say split path. So by default you get parent. You can make that explicit if we want. We can also say split path leaf. Okay, so this does the opposite. Instead of giving you the parent of the path, we get the last part of the path, the last name in the path, which can be the file name, for example. So both of those are useful. So we have split path. There's also join path. So let's say we have the current directory. Let's say, let's see, what is path again? Let's say equals. All right, so here's our path. Let's combine that with a name like join path, and we'll join it with hello.txt. Okay, and the result now is combining the first part of the path with the second part of the path, and it inserts the directory separator there to make it a valid path. And we can join multiple paths. We can say, my subdir hello.txt. Okay, so it takes as many arguments as you want, and it just joins them together to get the. And we can say, join can be a relative path. We can say data my subdir hello.txt. Okay, and so we can have a relative path be our joined path. The join path doesn't require that the path exists. For example, there is no my subdir, but it just makes sure that it's that the string is a valid path. Valid in the sense that it's well formed. Okay, so that's we've looked at set content, we've looked at get content, we've looked at test path, and we've looked at join path. Now let's look at one other thing in our script. Remember here let's run our script again just to remind ourselves what it does. Paths.ps1. And again, it read the file, it read this files.txt file, it checked whether each of those files exists, and in the case where one didn't exist, it outputted an error message. And by the way, another way we could write this, if we weren't interested in, I'm assuming here that this script might actually do something if the file exists, but if all we want to do is check if it exists, or check for missing files, we can say not test path. Okay. Yeah. All right. So now this expression is evaluated inside the parentheses, so test path will return true if the file does exist and false if it doesn't exist. By saying not, we negate that. So now this whole expression is true if the file does not exist. True if it is not the case that the file exists. All right? So this will do the same thing as what we had before. All right, but let's try something else. Let's go up to the parent directory, and now let's run our script again. And to do so, we say we have to specify because the script is now not in the current directory, we'll say paths.ps1. We'll invoke it from the parent directory by giving the relative path from the current location to our script. And now you see we get an error. And the reason we get an error is that it's trying to open files.txt, but it's trying to open it in the current directory. And the current directory is no longer the directory where the script is, where files.txt actually lives. It's the current directory here that we're running it from. So what we really want in our script is we know that this script we're assuming that the script is designed so that it looks for a files.txt in the same directory as the script itself. So how do we do that? Well, there happens to be a magic variable, if you will, a predefined variable called ps_script_root. Okay, and let's just output that by itself. And when we invoke our script, we see that it gives c::learn ps files. In other words, it's the directory that contains the script file, regardless of what the current directory is. So let's use that to determine the location of files.txt. We know that files.txt is in that directory, so we can simply say join path ps_script_root files.txt. So now if we run this again, we get c::learn ps files. That is, this is ps_script_root, and then joining that with files.txt gives us the whole path of the file. So let's bring back our original script, but instead of just opening files.txt, let's open the result of this expression. And I can just put it in parentheses, like so, paste it in, and there is our revised script. So now we take the name files.txt, join that with the script root directory, and this gives us the path of files.txt in that directory. Get content will then give me the content of that file, and then again we execute the for each object command will execute the script block once for each line in that file. So let's run that again, and now we get the same behavior we saw before, but it no longer depends on us running the script from the current directory. So to review, what we've seen here is we've seen Get-ChildItem, also known as ls or dir. We've seen setContent, which stores the result of a command or stores any value really in a file. We could even just say hello setContent hello.txt, and now if we open hello.txt, it contains the word hello. Okay, so that's setContent. We've seen getContent, which we invoked in our script here. We've seen testPath. We've seen joinPath, which combines two paths. We've seen splitPath, which breaks a path into parts. You can use it to get the parent of a path, use it to get the leaf node of a path, and I think there are some other things you can do with it. You can always get the help to find out what. We've seen resolvePath. Actually, I don't know if I actually demonstrated. Oh yeah, I think I did demonstrate that one. We've seen resolvePath, which takes what may be a relative path, but gives you the actual full path from it. We've seen PS script root, which gives you, when used in a script, will give you the root directory, or give you the path of the directory that the script is in. In fact, I've never tried seeing what PS script root will do if you're actually just. Okay, there is no PS script root when we're just invoking it from the shell. So that pretty much covers what I wanted to show to you today, and I hope that you find that useful in working with PowerShell. Thank you.